We're recording.
Thank you. Yeah, I'm going to update these slides because this slide doesn't have there's some missing information here. So tonight I'm going to send you, but I'm just going to explain, and then you'll get slides with examples of code. So if in Rust we use if for conditions, like when you're comparing maybe a two things, for example. You want to check if a name, for example, if a name is equal to Ben, for example, or if a certain number is bigger than 10. And so you compare, and then you either print out or you either return a certain value depending on what you want. So for example, let fee equal if amount is greater than 100, then you return if the fee is greater than, let's say the fee is the amount is greater than 100, you return 2, or else you return 1. So it can be whatever you want to put. So it's up to you to put the logic. And now this very important one is the loop. Rust prefers for loop than while loop. And the reason for that is because while loop are infinite. So no, for loop, in for loop, you can put a certain break. Like for example, you say for counter starting from a certain number up until the number you stop. And you can also use while something is less than 10, for example, loop through the number. If probably not gonna make sense me speaking, but I'm going to give you more examples. I'll update these slides. And there's also match. So match also is used instead of if statement, and it's a more powerful way of it's stronger than if and else. It's a more powerful ways of using comparison. And so here you match a certain you can match a certain variable with a number, for example. So if that variable matches a certain number or a certain string, then return something. So that is match. And there's also functions. So function requires explicit types. This remove ambiguity and prevent logic errors in the system. So sometimes you wanna repeat a way of doing things in your program. For example, you want to add a number. You want to create a program that adds a number, but you want to repeat that over and over again. Let's say you want to multiply, or you want to add two numbers. You want to add A to number B. Then you create a function. And in fact, let me just, I think it's so difficult for me to explain this way. Let me just pull out the code editor, because this is a bit hard for me to explain. Can all of you hear me? It's so
Yep,
hard
I
to
can hear you.
explain. Let me pull out the editor. And let's clear this. Cargo init lessons.
Ben, we can't see your screen. You're still sharing the PDF
Okay.
or your Google.
So I'm just initializing a new project now. Let me share my screen because it's so hard to explain. Let me open the VS Code and then I'm gonna share it. The VS Code.
Okay, we can still see the
I'm
Chrome
just waiting
only.
the VS Code to open and
Okay, cool.
then I'm going to share it. Alrighty. All right. Can you see the VS Code?
No, not yet.
Let me redo again.
We'll just try and cancel sharing and then reshare.
Yay! Finally. Oh, I still have to wait.
Because it swapped over.
Finally.
Yeah, we can still see the slides.
Can you, let me redo. Let me do it again.
Just cancel your share and then start the share again. There we go.
Come on, come on, come on. Thank you. Thank you. Thank you. Thank you. Oh man, what's going on today? Uh, what's going? Something went wrong when sharing your screen. Try restarting your browser. Let me try one more time. I'm gonna have to. If this doesn't work, I'm gonna have to leave and come back.
All good. Yeah, let's see what works.
No. So I'm just going to close this browser. Okay, I'll be back. Let me copy and paste the link. Okay, I'll be back. Sorry for the inconvenience.
Not sure if Ben's like able to come back. Let me just message him.
Ooh, I'm back. Let's do it again. Hello, can you hear me?
Yes, we can. And we can see your screen now. Just zoom in a bit, if you don't mind.
Yeah. Okay, so we're talking about functions. So this is the main function. So functions can is the anatomy of a function is it's like this in Rust. Like I was giving you an example of how you can have an adding function, and you have a, and you specify the type of number it is. It's an I32, and you have b, also an I32. So this just, you can have any parameters, maybe a string parameter, anything like other programming languages. Can you hear me?
Yes, we can hear you.
Okay. And remember, you have to return. So I32, for example, and this can be a plus b or whatever. Just like I think I mentioned it the other time. So this is an anatomy of a function. So Fn defines that you are dealing with a function, and here the add is a function name. Here is the parameters. It can be string, whatever, and here's the returning value. And remember, there's no comma here, so we're returning a plus b. So that is what is going to be returned on the function. And always remember this. This is an integer type, 32-bit. That's what you're returning. Another thing also that is also mentioned is ownership, and ownership is very important.
Sorry, Ben, before you carry on, can you show me a match example?
Yes, we're gonna get to it.
Oh, okay, cool. Thanks.
What time do we have? Okay, we have time, I guess. So Rust is a bit different compared to other programming language. Other languages like JavaScript, like Java, for example, like Python, use garbage collection. It's sort of like, let me put it in an example. It's sort of like let's say you in a room and you playing, right? You're playing in a room, you have different toys, right? And you also have a robot that cleans up your room. So that robot is always active. So it does a lot of different functions in your house. But then when you make a mess in your house, or you make a mess in that specific room, the robot now has to leave what it's doing and go and clean up your room and collect the garbage. And while it's doing that, it slows down other parts of the system in a way, because now the robot is not working in other places, because now it's attending to that specific room. And that's the idea of garbage collection. But in Rust doesn't do that. Rust is what we call ownership. meaning that let's say you have toys in your room and you're playing with toys. So when you're done, the robot is not coming to clean up. You carry those toys and maybe you get rid of it, or you borrow it to somebody else. This is kind of the idea that I want you to have in your mind. I'm going to show you an example. Let's say we have the main. And let's say let name is equal string. So basically we're taking a string called Ben, and then so once I've so here I declare a variable called name, and it takes this string. So in this case, name owns this value. So if now I create another variable, let me say name 2, and then I just call it name, and something crazy that does not happen in other programming languages will happen. I don't know if any of you got in this spot in ciphering. Does anyone know that what will happen if I say if I print out name 2? What's going to happen if I print out name 2?
I'm going to say it's going to be undefined.
Sorry?
I'm going to say it's going to be undefined.
Why is that? If you can explain.
Because Ben belongs to the names to name, and you can't assign a name to name 2 because Ben belongs to the variable name.
Someone else?
Okay, I've got my hand up. Okay, so we're not dealing with the variables because we're just printing out hello world. But I think
no. Let me print it out here. Let me just do that. So we're going to print out. You know what? Maybe this question is confusing. Let me print name 1. Name. Let me print out name. So we have a variable called name and Ben, and then I create another variable called name 2, and then it's equal to name.
I don't know exactly what the compiler is going to say, but it's going to be something about borrowing.
Correct. So correct. So how many percentage are you at the moment?
Don't ask me difficult questions. I just know a bit of Rust. I've practiced a bit.
Okay. So let's see.
It's also going to complain about the unused variable.
Oh, I see. Yeah. So because there's a borrowing that happened, so it's already showing me an error. There's a borrowing that happened now because we have name and then name 2 borrowed name, and so now this is out of scope. Let's click here. Move occurs because name has type string, which does not implement the copy trait. So we didn't copy. There's also copying in Rust. So if you want to copy, you can copy. But if you declare a new variable and then you call another variable that you created, then it loses its scope and you borrow it to, not even borrow, the ownership has moved. Sorry, the ownership has moved from name to name2. I don't know if it makes sense. And now, what happens if you want to borrow? Because now we took the ownership. Name2 took the ownership of the variable in name. So what if we run
You
one?
just a bit soft there, Ben.
Huh?
Your mic's not as loud as it could be.
Okay. I was saying that now that we've taken ownership from name to name2. So what do we do if we don't want to take ownership? We just want to borrow, meaning that once we borrow, name is not gonna be lost. Name won't be out of scope. So how do we do that? Who knows? If a name is the custody of object in memory, it's like that. Okay. So this is where we use borrow. And to borrow, we basically use a reference called, we use an, what do you call it? There's that sign. Is it the upper end? Mukta, if I'm not mistaken. What do you call that? This
Look
sign.
on the squiggle.
This one.
Ampersand.
Ampersand, yes, the ampersand.
So now to borrow, we simply do that. You put the ampersand, whatever you call it, and we do that. So I don't know why this is not working. The borrow of more value name. See? Okay, let me just run it and see what's gonna happen. Uh, sorry. Let me do this. Name 2. Okay, now let me print name. Okay, so in this case, with this name 2 was the name that you borrowed, and the name is the original name. So here, the ownership did not move because we copied by using this sign here. So that's how it works. And yes, the pointer. Yeah, it works like a pointer. And now for the last, before we go, because I know we're running late, I'm going to send you notes. I'm gonna send it tomorrow with all this. So we're going to do matching. And before we go, is anyone in a hurry? Because I don't want to steal your time. Okay, so we can go on. Okay, so now we're going to, I'm going to give you an example of how match works. So it kind of works like if and else. I'm just going to do it quickly. So let me remove my mic. Can you hear me? Thumbs up if you can hear me. Okay, let me just go quickly for the last subject for now. So let's say we have, let num equal to 2. So now we want to match it with something. For example, we want to match it with the word, like for example 2, like the written word of 2, number 2. So we're going to give it an option. One way of doing it, we can use the if, like if 2, the number, is equal to 2 TWO, do that. If it's equal to like if you put one is an option O and E, then it's not matching. Or if it's THRE, it's not matching. So you want to match only if it matches with TWO, which is 2. So you want to match the number. So this is what we're gonna do. So in order to do that, we're gonna do that, and then we're gonna print something. So this is how we're gonna be using match. So we have match num, which is the name of the variable. So if it's 1, if num is 1, then we're printing we're printing 1. If it is 2, if it matches if 2 matches with 2, then we're printing we're printing 2. If num is 3, then we go on and on. We can go on and on. Print lane 3. And if you want to have an else, then you put the underscore. Print lane, the ln. Just write none. It's a this will match. So we're matching the variable with all this number. Then if it matches, we print a certain number. And let's run and save it. No, nib2 is not a string slice. I just saw a question now. It's not a string slice, but there's a way of calling strings. The way we call a string and a string slice is different. The way I declare that string, that was just a normal string. A string slice is str. And I'll show you an example. So let me run this. So you're going to see it in action. So basically it matches with all these numbers, and if it's equal, then it prints it out. Does it make sense? All right, so what I'm gonna do is I'm going to create this evening. I'm going to update this slide and then send you all the information in a condensed way so you can be up to speed and be ready for next week. Because next week is gonna be, next week's gonna be a bit hectic, a bit more. There's gonna be a lot of new things that you're going to learn. So anybody has a question before we leave? Or Mukhtar, if you wanna add something?
No, I think we're good. Thank you so much, Ben.
And once again, I apologize for being late today. My machine was just acting up, and there's also another course that was supposed. There's also another program that I'm running, but I just asked them to be free so that I can run this class. So anyway, thank you so much. Tomorrow, same time. And I'll also, before the classes, you're going to see the slides.
Thanks, Ben. Enjoy your night, guys. Cheers, Ben.
Cheers.
Cheers, guys.
Bye, everyone. Thanks, Ben.
Thank you. Thank you.
Just